So now we're going to start 3D geometry. So it's nothing different to 2D geometry. So only different is that there is another axis to it. So 2D geometry means what? Two-dimensional geometry. So we have done this one. Here we have x-axis and here we have y-axis. So this one was 2D geometry. Now we will came across this new chapter where we're going to learn about 3D. So 3D is all about three axes are there. So now this is known as x-axis. Now it goes like x and it goes like this way, and we have y-axis. So y goes like this way, and then we have z-axis. This goes as this way. Just like here x, y are perpendicular to each other, here x, y, z are mutually perpendicular to each other. So this is x, y, x-axis, y-axis and z-axis. They comprises a 3D dimensional geometry. So now here when we plot a point, so I have a point in here. The coordinate of the point was what? X comma y. That's how we plot the coordinates, where x means this distance and this y value means this distance. So if you travel this distance, then you go here, so you go to that point xy. But in 3D what happens is that x means this distance, y means this distance and z means this distance. So suppose we have a point in here. Here we have that point. So basically that point will be, I'll just draw something in here. So here this point, this length will give you the x, this length will give you y. Actually I have told you different. I told you a different thing. The opposite one in here. Basically this length will give you y, because you see this length is parallel to this line, right? So this length will give you y. Look at here. Here this length is parallel to x-axis. So basically I am taking the length in the x-axis way. So this is x, and this length, this vertical line which is parallel to the z-axis, this is nothing but z. So this x, y, z, this three lengths comprises this point as x, y, z. So that's how we find coordinates in 3D geometry. It's just an added axis. Here it is xy, here it is x, y, z. So now one thing, if I ask you, in this x-axis what is the coordinate? In this x-axis what is the value of y? So you can directly say the value of y is 0. Y is 0 at every single point on the x-axis. So same goes in here. In x-axis, in the x-axis in here, z is also 0 and y is also 0. Same in the y-axis, x is also 0, z is also 0. So like this, right? Now here I have a fact in here. Since we have three axes in here, here we have z, here we have y, here we have x. Now here we can form planes. What type of planes? One, it will be xy plane. The xy plane will be given, this one is the xy plane. So basically 2D is nothing but xy plane. This is the xy plane. The other one is the yz plane. Now which one is the yz plane? This one is the yz plane. Plane which has only y and z coordinates. This one is the yz plane. And the last one is the xz plane. xz plane. Now this line gives you the xz plane. This is the xz plane. So there are three planes in here. Now if you take any point in xy plane, the coordinate of that point will be x, y, 0. In xy plane, z is always 0. So in zy plane, the coordinate will be what? 0, y, z. In zy plane or yz plane, the coordinate, the x will be 0. So in xz plane, the coordinate will be what? It will be x, 0, z. The value of y will be 0. Okay. So this is how we can find coordinates in different planes. So now this is what we have. And here in this two-dimensional, we learned that there are 4 quadrants. This is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. So we have 4 quadrants in here. In this 3-dimensional, we have 8 quadrants. We are going to have 8 quadrants. Okay. So let's start. Just keep that in mind. Here we are going to have 8 quadrants. So how we will know that we have 8 quadrants? Look at here. So x, y. In the first quadrant we have what? X is positive, y is positive. In the second quadrant, x is positive, y is negative. Let's look at here. Positive, positive. X is positive, y is positive. In the second quadrant, x is negative, y is positive. I made a mistake in here. X is negative, y is positive. In the second quadrant, x is negative, y is positive. In the third quadrant, x is positive. In the third quadrant, both are negative. X is negative, y is negative. In the fourth quadrant, x is positive, y is negative. So x is positive, y is negative. That is the fourth quadrant. So this is how we have 4 quadrants in 2D. Now let us see how many quadrants do we have in 3D. I told you it is x. It was 8. So x, y, z. First thing, I should have all of them as plus, 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 plus. This goes first quadrant. Now in second quadrant, what happened? In here second quadrant, what happened? X was negative. So I have minus, plus, plus. In the third quadrant, what I will have? We have minus, minus, plus. You see minus, minus, right? Now in the fourth quadrant, x is positive, y is negative. So we have positive, negative. This one will be positive. So this is basically z is always positive, but only thing is changing is x, y, and it follows the quadrants of the two-dimensional one. Plus, minus, minus, plus, 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 minus, minus. Plus, minus, minus, plus, 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 minus, minus. Now from here, the fifth quadrant goes like plus, plus, minus. Sixth quadrant goes like minus, plus, minus. The seventh quadrant goes like minus, minus, minus. And the last quadrant, that is the eighth quadrant, that goes like plus, minus, minus. So basically we have to arrange this plus, minus, plus in a different way such that each one of them, they are of different order. Plus, 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 minus, plus, plus. So you see, so that's how we get 8 quadrants in a 3-dimensional geometry. So this is basically octants. Octants we get. In 3-dimensional geometry, we will be getting octants. Okay. So in 2-dimensional geometry, we got quadrants. In 3-dimensional geometry, we will get octants. Now let's do exercise 12.1. So exercise 12.1, it says a point is on the x-axis. So it says a point is on the x-axis. So x, y, z. So here is a point. Think that here is a point. It's on the x-axis. So what are its coordinates? What are its y coordinate and z coordinate? And I already told you, if a point lies on x-axis, the y coordinate will be 0 and the z coordinate will be 0. So right here y coordinate is equal to 0 and z coordinate is also equal to 0. So this two is the answer for question number 1. Now question number 2. Again, question number 2 says a point lies in xz plane. So let me just draw the diagram. So here we have z, here we have x, and here we have y. So if a point, suppose it lies in here, xz plane. So I told you in xz plane the coordinates are what? Y is always 0. So it is what? The coordinate is basically what? X, comma, 0, comma, z. Y is always 0. So here the y coordinate will be 0. It's so easy. In xz plane, y coordinate is equal to 0. Clear? Now question number 3. Question number 3 says, name the octants in which the following points lie. So you have to tell the octants in which the following points are going to lie. So let us find out. So the first is 1, 2, 3. So 1, 2, 3 means what? All of them are positive. X is positive, Y is positive, Z is positive. And that is octant number 1. You see X, Y, Z, all of them are positive. So I will write here octant 1. Now the remaining one, please do it as homework. Let me do the last one. 2 minus 4 minus 7. Now X is positive, Y is negative, Z is negative. So X is positive, Y is negative, Z is negative. So you see it is the 8th octant. So I will write here octant 8. So like this way you have to write all of them. Okay. Now let's go to question number 4. So here it says the x-axis and y-axis taken together determine a plane known as. So which basically the question says which plane is formed if I take x and y plane, if I take x and y axis. If I take x and y axis, which plane is formed? Obviously it is xy plane. It is xy plane. That is my answer for question number 4.1. Then question number 2 is the coordinates of points in xy plane are of the form. So in what form you will get coordinates? We know that in xy plane z is always 0. So the coordinates will be x, y, 0. So this is how we will get the coordinates. Now coordinate planes divide the space into how many? Coordinate planes divide the space into 8 octants. Right? So this is how we got the answers. Now the next topic, that is distance between 2 points, it is not in your syllabus, it is excluded. The next topic is section formula. So we have section formula. Now section formula we have already studied about this one in class 10. So what was basically section formula? It is, we have 2 points. Suppose we have PQ. I'm just doing the 2D one. I'm studying the 2D diagram one. If I have 2 points, one is x1, y1 and the other one is x2, y2. Now suppose I take another point R which divides this PQ in the ratio of m is to n. Which divides the PQ line in the ratio of m is to n, and the coordinates of R is given by x, y. So by using section formula you can get the coordinate of xy. You can easily get the coordinate of xy. How? What is the formula? The formula is x is equal to m into, you just multiply m with the x coordinate of q, the opposite one, m into x2 plus n into, you multiply n with this side, that is nx1 divided by m plus n. This is how you get the x coordinate. So how to get the y coordinate? Y coordinate will be my2 plus ny1 divided by m plus n. So this is how we applied section formula for 2D. So in 3D will be what? In 3D there is no difference. It will be, we have a line made by 2 points. We have x1, y1, z1. Here we have x2, y2, z2. So again we have a point R which divides the line PQ in the ratio of m and n. So we have to find the coordinate of R. So here x will be same formula, y will be same formula, but there is another thing we have to do, that is z. So z will be mz2 plus nz1 divided by m plus n. So this is how we use section formula in finding the coordinates of the point which divides the line in the ratio of m is to n. So this is how we go. Now another thing, this one is for internal division. This one is for internal division. The formula is for internal division. There are 2 types of division. The other one is external division. External division. So external division basically means what? Suppose we have a line PQ and there is another point R which is outside the line PQ, And what is the ratio that R divides the line PQ? So basically here you see how the ratio occurs in here. So this PR is M and this QR is N. So here the formula goes like, so suppose I write here x1 comma y1 and this point I write as x2 comma y2. So this R is basically x comma y. So how to find the coordinates of x comma y? So here x is equal to, you write M is basically what? The ratio for PR, right? But you will multiply with the coordinate of Q. So M into x2 minus, here you subtract with n into x1 divided by m minus n. For internal division it is plus, for external division it is minus. And y will be my2 minus ny1 divided by m minus n. And for z it will be mz2 minus nz1 divided by m minus n. So this is how we find the coordinates. Now basically I shown you for the two-dimensional one, but the three-dimensional one is same as 2D. Just you have to add another point in here. Just you have to add another point and there is no difference. So this is the formula, section formula for external division. Now, so this is how we got it. Now there is another formula which you must learn is to find centroid of a triangle. How to find centroid of a triangle? So suppose we have a triangle like this and the coordinate of the vertices is, one is x1 comma y1 comma z1, the other one here is x2 comma y2 comma z2, the other one is here x3 comma y3 comma z3. So how to find the centroid of this triangle? So centroid of this triangle is found by the formula is very easy. It is just add the coordinates, x coordinates divided by 3 comma y1 plus y2 plus y3 divided by 3, then z1 plus z2 plus z3 divided by 3. That is your centroid of the triangle. Simple as that. Okay, let me do some problems. Exercise 12.3. So we have exercise 12.3. So the first question what you see in here is find the coordinates of the point which divides the line segment. So they have given you, so there is a line segment joining 2 points, -2, 3, 5, and here we have 1, -4, 6. So you have to find the coordinate of that point which divides it in the ratio of 2:3 internally. So this one is 2 and this one is 3. It is dividing it in the ratio of 2:3 internally. So what I have to do? I have to find the coordinate x, y, z. So x will be equal to what? X is equal to, we have learned the formula, that is mx2 plus, internally we are doing, plus nx1 divided by m plus n. So what is the value of m? M is 2 and x2 is what? This one is x2, the opposite side, that is 2 into 1 plus n is 3 into x2, x1 is what? -2. So -2 divided by 2 plus 3. 2 plus 3. So we are getting 2 minus 6 divided by 6. We are getting -4 by 6. So we have -2 by 3. So that is my x coordinate we got. So what is y coordinate? Same thing. So it is m into y2, that is -4. Then plus n is what? N is 3. 3 into 3 divided by m plus n, that is 5. So we get -8 plus 9 divided by 5, that is 1 by 5. This is my y. And z is equal to what? Z is equal to m, that is 2 again, m into z2. Now z2 is what? 6. Then plus n is 3. 3 into z1 is 5 divided by 5. So that is coming out to be 12 plus 15 divided by 5, that is 27 by 5. So the coordinate we are getting is, we made a mistake in here. This is 5, it will be 5. How come we got 6 in here? It will be 3 plus 2, it will be 5 in here, 5 in here. So basically it is minus 4 by 5. So the coordinate of the point which divides the given line segment internally is minus 4 by 5 comma 1 by 5 comma 27 by 5. That's the coordinate. So that's how we do question number 1. So this is part 1 of it. Now for externally, what we are going to do? There is no difference in that. In all these formula, just put a minus sign in between all of them. So for externally, the formula will be mx2 minus nx1 divided by m minus n. You just put those values. Then y will be equal to my2 minus n y1 divided by m minus n, and z will be equal to mz2 minus nz1 divided by m minus n. So this is how we get the coordinates of x, y and z, okay, for external division. So just put those values. You see here m is to n is also equal, that is 2 and 3. M is 2 and n is also 3. So just put down those values and find the coordinate for external divisions. So that's it for today.